Okay guys, in this video I'm going to explain a few examples of Zener diode. Okay, now think how you solve some question like this. Now we have used Zener diode in power supply. Don't forget guys, like when we use Zener diode in power supply, cathode of Zener diode should be connected to the positive terminal and anode should be connected to the ground because we are using it in reverse breakdown region. Determine the minimum and maximum input voltage that can be regulated by the Zener diode. Okay, how we decide this, guys? We have number 474. Now, first thing that we need to know, like what are the rating of this one? Like to pick the rating, guys, like you can go to the data sheet. So here you can see a data sheet for this particular number 4740. So now if you look at this so this line, so you can see the data for this particular Zener diode. Rated voltage, so that is around, that is 10 volt. And other important reading, what is the minimum current that we need to maintain in order to get regulation, and also what is the maximum that current that we can have through this Zener diode. Now in this way we can find these figures. Now when we go back to our problem, okay, now here, okay, now we can see I set K minimum current that we need, knee current that we need to maintain, that is 0.25 milliampere, and rated voltage, says in a voltage that is 10 volt. So then other information, I max, so that is 91 milliampere. Now we need to decide, like, okay, minimum and maximum input voltage. Okay, in order to decide minimum voltage, so what is the minimum current that we need to maintain through this Zener diode? So that is 0.25 milliampere. Now when you want to maintain 0.25 milliampere, the current through the resistor also same. So in that case, what will be the voltage drop across this resistor at that time? So we can calculate that. So V R maybe min, it should be given by 0.25, this is in milliampere, divide by 1000 because we need to convert it into ampere, multiplied by the resistance that is given, that is 220 ohms. Now this should gives us the voltage drop. So R min, that should be 0.05. If you calculate this one, you will find this one. Now what is the minimum voltage that we need to maintain from input side? V in min, we need to have at least 10 volt, otherwise we can't have the regulation. 10 volt plus, so in order to have this minimum current, we need to have another 0.055 voltage drop there, so that gives you 10.055. This is the minimum voltage that we need to maintain. So then we will find what is the maximum voltage that we can have. So then to get that figure, we need to look at what is the maximum current that we can have through this Zener diode. So now this time, so the maximum current that we can have, so that is 91 milliampere. When we have 91 milliampere through this one, through the resistor also we have same voltage. Now uh, VR max, I will say maximum voltage drop through this resistor. So that is 0.091. I just converted this current value into ampere. So that is 220. Same as earlier situation. VR max. So that is equal. If you multiply these two, 220. So you will get, so that voltage that is equal 20.02 volt. We can have this much of voltage difference, like when we have 91 milliampere current flow through this resistor. So now in that case, we need to have 10 volt through this one, drop through R, that is 20.21. So then V in max, that is given by 10 plus 20.02. So that is V in max, that is equal 30.02 volt. In this way, we can solve this problem. Okay. Okay, now we will solve this second question. So now here what happened is, it is given that like 50 milliampere current is maintained through the resistor. Input voltage is 9 volt. Now what will be the uh, value of current rating, current limiting resistor? We need to find what is the value of this R. Okay, first thing, we need to find what is the rated voltage of this one, 4733. If I go back to data sheet, I can find that 4733. So now this one is 5.1 voltage. So then okay, so here I will solve this one, this problem as well. Okay, now V is a rated voltage, that is 5.1 volt. That means here we have 5.1 voltage different. Sorry, not here guys. So here it's 5.1 volt. Now that means when we have 5.1 over there, what will be the voltage through this one? It should be 9 minus 5.1. So that should be 3.9 volt difference. Now we know the current. So current is given. Now because we have this one, we can apply simple Ohm's law here. Current is given. I is equal 50 milliampere. So then if you apply simple Ohm's law, you can find R, that is equal V divided by I. So now R, that is equal V 3.9 divided by 0.50. So I just converted this to ampere. This will give you R is equal 78 ohms resistance. So now in this way we can do this calculation. I hope you guys understood this calculation, and thank you very much for watching this.